BCS classification is based on the solubility and permeability, and BCS class 2 drugs are low soluble and high permeable. So these drugs are formulated into different formulations, and if the oral bioavailability is required to be understood, then the dissolution plays the critical role for the BCS class 2 APIs. In this video, we will learn step by step regarding the BCS class 2 drugs. I welcome all the viewers to this video, and let's start with the introduction. BCS is a biopharmaceutics classification system which divides different drugs into four categories: BCS class 1, 2, 3 and 4. So out of these four classes, BCS class 2 have the low solubility and high permeability. These are absorbed well through the membranes but dissolve poorly in the GI fluids. So if you achieve the dissolution, then you can achieve the bioavailability because there is no problem in the absorption. Only dissolution and solubility plays the critical role. Dissolution limited absorption is there for the BCS class 2 drugs. Permeability is not an issue. Main problem is drug doesn't dissolve, and because of that it will not get absorbed. You can remember, like, I can cross but I can't dissolve. This is the main understanding about the BCS class 2 APIs. Then we will see the typical challenges for the BCS class 2 drugs and how to overcome them. So first challenge is low solubility, that is the poor aqueous solubility. Slow dissolution because it remains undissolved in the GI tract. Food effect because solubility varies with the meal composition. Some of the drugs show variable high or low impact because of the meal composition and high fat content of the meal. pH dependent solubility. So these type of drugs may dissolve at specific pH and precipitate at others. I have made separate video on BCS class subclasses for the BCS class 2, BCS class 2A, 2B and 2C. So I request you to go through that video as well. Then formulation strategies to overcome the issues. So problem is low solubility, slow dissolution, pH dependent solubility and precipitation risk. Low solubility problem can be solved by improving the solubility by the formulation strategy, like you can use the cyclodestrins, then you can use the solid dispersions, you can go with the lipid based systems, you can use the surfactants, you can do the micronization. Then slow dissolution. So depending upon the solubility, there is a dissolution problem. So if micronization is done, then it can improve the solubility and it will result into the increase in the dissolution. Then nanocrystal can be made, surfactants can be used. So generally micronization, API particle size reduction, use of the surfactants, use of the polymers to improve the solubility. These are the common strategies adopted. pH dependent solubility is the problem. So you can make the tablets with buffered composition. Buffered tablets can be made and pH modifiers can be used. Precipitation risk. This is one of the most important problem, and because of which there is a variation in the bioavailability and problem in the bioequivalence. So precipitation risk can be solved by using the precipitation inhibitors and making the supersaturating formulations. Then examples are here for the BCS class 2 drugs like diclofenac, carbamazepine, glycopholvin, ketoconazole. These belong to different indications. Regulatory considerations for the BCS class 2 drugs. So these are not eligible for the biowaiver because biowaiver is granted for the high soluble APIs. It requires discriminatory dissolution testing, and discriminatory dissolution testing with the demonstration of discriminatory power is very important because the BCS class 2 drugs are having the low solubility and dissolution impacts the bioavailability. IVIVC is crucial. These drugs have high permeability, these drugs have low solubility, so formulation must be made or attempted to improve the dissolution. Now, some of the strategies I have enlisted once again: low solubility, dissolution rate, limited absorption, pH dependent solubility, food effect, and precipitation in the GI. So, these problems can be solved by doing the formulation changes, using the solid dispersions, using the co-surfactants, using the lipid based systems like uh, some lipids can be used as a excipients. You can make the soft gelatin capsules for these APIs and improve the solubility and bioavailability. Then micronization, use of surfactants, salt formation, making the amorphous form, making the pH modified formulations using the buffers and some pH modifiers, using precipitation inhibitors, doing the enteric coating, and making the super saturating systems can solve the problems. BCS class 2 drugs are dissolution limited, and primary goal is to enhance the solubility, maintain the solubilization, and achieve the dissolution. So use of some smart formulation strategies or techniques can improve the bioavailability through improving the solubility and the dissolution. So I hope this video will help you to understand BCS class 2 drugs and what are the problems associated with or challenges for the formulation with BCS class 2 drugs and how to overcome them. Thank you for watching the video.